So let's see a word problem where the standard forms are applied. Now in case of this, I can compare the numbers using standard form. Let's see this example where the diameter of sun is given to be 1.4 into 10 to the power of 9 meters and diameter of earth is given to be 1.275 into 10 to the power of 7 meters. And I have to find how bigger is the sun. Now in this case, I try to use the condition of the standard form through which I am going to compare the two diameters. One is the diameter of the sun and the other is the diameter of the earth. So I have diameter of sun is 1.4 into 10 to the power of 9 meters and diameter of earth is 1.275 into 10 to the power of 7 meters. Now in this case, what I do is I consider the ratio. Whenever I compare the numbers, comparing in the sense I divide one quantity by the other quantity and I see how much I get on the right hand side of the value. So when I say compare, I just divide diameter of the sun with the diameter of the earth, so that let's see what the simplification of this numerator by denominator leads to. So diameter of sun is 1.4 times 10 power 9 and diameter of earth is 1.275 times 10 power 7. So that in this case, I just get 1.4 into 10 power 9. Let me cancel this. This goes once and this goes twice. 10 power 2 times. So that I get 1.4 into 10 square by 1.275, which gives me 1.4 by 1.2 approximately into 10 square, which is 100. So which on further simplification gives me 2627. So this would give me approximately 7 by 6 is 616. 1.1 times 100. Now 1.1 is approximately 1. Therefore, I approximately understand that the diameter of the sun is approximately 100 times of the diameter of the earth. This is approximately assumed because 1.1 is almost near to 1. So in word form, I understand that the diameter of the sun is 100 times bigger than the diameter of the earth. That's why sun looks larger in size as compared to the earth. So the diameter of the sun is 100 times bigger than that of earth. So this is how we can compare the two quantities using the standard form representation and then simplifying to find the final value. So it has many applications, various applications through which standard forms can be used in comparison of two numbers. It can be used in converting to usual form. It can also be used where there are some properties in standard form which can be used in adding of two quantities. Now suppose I have, say I want to add the two quantities. I have total mass of earth and total mass of moon are given as two different values. Say I have 5.97 into 10 power 24 and 7.35 into 10 power 24 kilograms approximately. So if I have the calculated values of total mass of earth as this and total mass of moon as this, and I wanted to find the total mass of earth and moon, then I just add them. That means you are adding the two standard forms. So let's see how the standard forms can be added. So if I wanted to find the total mass, which is nothing but total mass of earth plus total mass of the moon, then it is nothing but adding of two standard forms. Therefore, let me take the total mass of earth as 5.97 times 10 power 24 plus 7.35 times 10 power 22, which on simplification gives me the overall total mass which we need to calculate. But to do that, we need to see that these two powers are same. The integral part of these two powers raised to 10 power must be same. So because I have 22, let me also convert this into 22. So which can be done by taking this as 5.97 times 10 square times 10 power 22 plus 7.35 times 10 power 22. Now once I make the powers split using the first law of index, a power m into a power n is a power m plus n, the first law of index makes me extract 10 square out, and then 10 power 22 is left, so that I can take 10 power 22 common out here, and the rest of the terms are written inside. The intention of making the powers equal is to make that come out of the brackets, and then I have this onto the outside. Now 5.97 into 10 square is nothing but 597, because into 100 would make the decimal move 2 steps to the right, so that I get 597 plus 7.35 times 10 power 22, which on simplification gives me 597 plus 7 would be 604.35 into 10 power 22. But if I want to convert this into the standard form, then I move this decimal 2 units to the left to get the value lying between 1 and 10. Therefore, because I'm moving this 2 units to the left, I get 6.0435 into 10 to the power of 24, which is called the standard form, and this is the total mass of the Earth and Moon combined together. So this is the standard form which is obtained by adding the two different standard forms. So standard forms can also be added, divided, subtracted and multiplied using the basic concepts. But in every concept, the only important factor is that we make the power of tens to be same. We make the powers same, and then that leads to the further simplification through easier process. And this is how the standard forms are expressed in usual form and usual form to standard forms, and how the operations are done with addition, subtraction, division and multiplication. Now, in the topic of exponents and powers, there's a concept called standard form. So in standard form, we try to express any given number which is in usual or general form into the standard form, which is fixed with its own definition. So we'll see how we define the standard form and how the different numbers can be converted into the standard form. So for example, the standard form defines, so let's take the definition first and then followed with few example problems. So the definition says that any number which can be expressed in the form a times of 10 to the power of n, where the condition is that n must be an integer, which we already discussed in rational numbers topic. So n is an integer and a is a value which lies between 1 and 2, including 1. So standard form is defined as a into 10 power n, where n must be an integer and a must be the value strictly between 1 and 10, inclusive of 1. So using this definition of the standard form, we'll see how different numbers can be converted to the standard form and then to the usual form. So let's take an example problem and solve for different cases. For example, I have 91632. Now this is the number which is in the 10,000 form. So 91,632. I want to convert this into the standard form. So let's take an example problem where we are going to convert this given problem into a standard form. So now here the number is 91632. It is in its 10,000s place, where it is 91,632. Now I want to convert this into the standard form using the definition with these two conditions with the given definition. So in this case, the number 91632, if I wanted to convert into a, then I had to search for the value of a which lies between 1 and 10. So inclusive 1. So I had to convert this into the form of a number which lies between 1 and 10. So immediately I can write this as 9.1632, which is a decimal number which clearly lies between 1 and 10. But because the decimal is shifted onto the 1, 2, 3, 4th place, therefore I get 10 power 4. So here it is understood that 91632 is generally understood as 91632.0. Therefore, to move the decimal 1, 2, 3 and the 4th place, then I need to raise to power 4. If I want to move the decimal to the 6th place, then I raise to power 6. To the 2nd place, then I raise to power 2. So because of this concept, I can just write the given problem as 9.1632 into 10 power 4, which is called the standard form of the given problem. So let's take one more example through which we identify the standard form. If I have an example problem, say 0.003953, and I want to convert this into the standard form, then in this case I'm moving the decimals to the right, whereas in the previous problem I was moving the decimals from right to the left. Here it is from left to the right until I get a value between 1 and 10. So let me start moving to the first position. Again, it's of no use because I get a value which is less than 1. So next I move the decimal to the right furthermore, then again I get a value which is less than 1. So I start moving until I reach the value between 1 and 10. So let me move it to the next, where I think I get a value between 1 and 10, because if the decimal is moved 3 places to the right, I get a value of 3.953, which clearly lies between 1 and 10 and hence can be achieved for its standard form. Therefore, once I move to the 3 positions from left to right, I get this as 3.953, but because I move the decimal from left to the right, I don't get the positive power, but I get the negative power. When I move the decimal from right to left, I get the positive power. So 4 steps will give me 10 power 4 and 3 steps will give 10 power 3. Similarly out here, the decimals moving from left to the right, when I move 3 steps to the right, I get 10 power minus 3. Minus sign is the negative sign which indicates that the direction of the moving of the decimals is from left to the right. In this case, the positive power makes us understand that the decimal is moving from right to the left. So here, this is called the standard form of the given problem. So any problem can be expressed in its standard form with this value being lying between 1 and 10 and its power n, which is minus 3, which is clearly an integer. So let's try with some more problems where we get the topic more thorough with. I want to convert this into the standard form. So what I do is I write this as 549.0 because 549 can be written as 549.0. Now because 549 is a number which is greater than 10, so I try to reduce the value from 1 to 10. So let's search how we can identify the value of A, that is the value of ranging between 1 and 10. So here I clearly understand that I need to move the decimal from right to left, therefore I get the positive power. So how many decimals or how many steps should I move from right to left is what is very important here when you convert the given problem into the standard form. So here I just move step 1 and step 2 and I halt. So when I move 2 steps, I get 5.49, and because I moved from right to the left, this 2-step process gives me 10 power 2 with the positive power because the decimals are moving from right to the left. So this is how I get the standard form. So this is called the standard form of the given problem. Now, if suppose I have my problem is 0.00000059. Now in this case, I want to convert this to the standard form. Now I clearly identified that I'm going to move the decimals from left to the right. So this can be done in various steps: 1, 2, 3, 4, 5, 6, 7, 8. So I need to move 8 steps to reach the standard form. Therefore, thus making me understand that if I need to achieve the standard form, I have to move 8 steps from left to the right, thus a negative power of 8. So this raises to 10 power minus 8. So my standard form here is 5.9 times of 10 power minus 8 for the given problem. So next I have a problem. Say I have a strict value of 5. How do I write this in standard form? This is a single digit which already lies between 1 and 10. And I can write this in the standard form, in the form that I can write this as 5 into 1, because 5 into 1 is 5. So that this can be raised in the form 5 into 1 can always be written as 10 power 0. So anything raised to the power 0 is 1 except 0. So therefore 5 into 1 can be written as 5 into 10 power 0. And this form of representation of 5 is called the standard form. So the number 5 written in the form 5 into 10 power 0 is called the standard form of the value 5. The same way, you have many other problems where you can convert. Say I want to convert 0.2 into the standard form. So this can be with jumping this 1 unit to the right. So I'm moving 1 step to the right from left to the right. Therefore, I get the negative power of 10, so that I get this as 2 into 10 power minus 1, which is called the standard form of the given problem. So 0.2 can be written in standard form as 2 times of 10 raised to negative 1. So this is the standard form of the given problem. So any problem or any number in mathematics can be expressed in its standard form. If a fractional number is given, say for example, I have 3 by 2 and I want to express this in standard form, I can do that by just converting. 3 by 2 is nothing but 1.5, and 1.5 is nothing but 1.5 into 1, which is nothing but 1.5 times 10 power 0. So 1.5 into 10 power 0 is called the standard form of 3 over 2. So different rational numbers or real numbers or integers or whole numbers or natural numbers, all different types of set of numbers can be expressed in standard form using the basic definition as we have seen in different example cases. So ultimately the definition stands that a standard form is expressed in the form a times 10 power n, where n must be strictly an integer and the value a must always lie between 1 and 10, with approximately with 1 as an exceptional case. Therefore, if I take 1 is itself a standard case because 1 is included in a with equality. Therefore, 1 can be written as 1 times of 1, which is nothing but 1 times of 10 power 0. Now this is called the standard form of 1. So 1 can be written as 1 times of 10 power 0 is called the standard form of representation of the given problem. Now let's see the usual form from the standard form. Now we have seen the basic definition of standard form in the previous case. Now the reverse process of standard form is the usual form. Given a problem, if I convert that into a standard form, then the original form of the standard form is called the usual form. Say I give a problem in standard form and I simplify that to the most simplified process, then the value which I obtain is the usual forms. Let's see with an example. Say for example, I have the standard form of representation as, let me say, the speed of light is 3 into 10 to the power of 8 meters per second. We all know that the speed of light is 3 into 10 to the power of 8 meters per second, and this is the standard form of representing the speed of light in physics. So if I have the standard form of representing the speed of light, then I want to convert this into the usual form, so which is nothing but simplified process of this multiplied with this. So let's see how we can do for this. So taking the given standard form, I can write this as 3 times of 3, 4, 5, 6, 7, 8. So when on multiplication, I get the simplified value as 1, 2, 3, 4, 5, 6 meters per second. So this is 30 crore meters per second is called the usual form of the given problem. So standard form can be converted to the usual form in a simpler way by just simplifying and finding the product of a and 10 power n. So this is one of the example through which we understand the usual form. So let me take a decimal representation of a standard form which can be converted to the usual form. Now for example, I have 9.436928 into 10 to the power of 4 is the standard form very much, because this is a value which lies between 1 and 10, and this is in the form 10 power n, with n being an integer 4. Now if I want to convert this into the usual form, I just simply understand that the positive power will make the decimal jump from left to right in this case, because this is the case of converting the standard form into the usual form. So therefore the decimal jumps from left to the right. So because it is 4, the decimal jumps 4 steps to the right from left. So this would be jumping 1, 2, 3, 4. So the decimal moves here so that I get 94369.28, which is called the usual form of the given standard form. So this is the usual form of the given standard form. So it is very easy to convert the standard form to the usual form and the usual form to the standard form. If I assume that I don't know the standard form of this, if I have this problem in the usual form, I can again revisit the previous session of finding through the definition of standard form and then find its standard representation. Because I want to convert this into a standard form, I need a value which lies between 1 and 10. So I move the decimal 1, 2, 3, 4 steps from right to left, therefore with a positive power, so that I get 9.4369 raised to 10 power 4, which is the standard form of this, which you already have. So this is how we understand 928. We understand the conversion of standard form to the usual form and usual form to the standard form. So let's continue with one more example where we'll take a standard form with a negative power. An example with a negative integral power. Now because it is the negative power, this is very much in the standard form representation, and I want the usual form converted from the standard form. So I understand that I had to move the decimals 4 steps to the left from right. So therefore this decimal representation of 1.9623 into 10 raised to negative 4 will make the decimal jump 4 steps, 1, 2, 3, 4. Because it moves 4 steps to the left, you have 3 zeros added, so that the decimal representation would be 0.00019623, which is called the usual form of the standard form representation. So usually when problems are given in standard form with negative integrals, I just move the decimals from right to left. When I don't have any decimals, I include zeros in between so that I get the value with 4 steps jump to the left as 0.00019623 as the usual form of the given problem. So this is how we understand the usual form of representation. Now, when I have with an example 7 into 10 to the power of 0. This is the standard form, and it's very easy to simplify because this standard representation can be converted to the usual form by taking 10 power 0 using the laws of indices. As we have visited through exponents, 10 power 0 is always 1. So this would be 7 times of 1, which is 7. So this is called the usual form of the given standard form. So like this, we can convert the different types of standard forms into usual forms and usual forms into standard forms based on the decimal moving from right to left and left to right, and that results in the positive power and the negative power of 10. So these problems have various practices in different ways which can be done through the exercise problems. Now we are going to discuss with identifying of errors in case of exponents and powers. We have learned various topics in exponents and powers. Mostly we started with laws of indices, the various laws of indices which are applied in various problems and justified the statements both from left hand side and right hand side. So similarly, we would like to identify the errors by just recapping with all the topics which are learnt in exponents and powers. So when a problem is given wrong, we try to identify where the problem is wrong and just give valid reasons when that would be correct. So that is what is the topic called identifying the errors in case of exponents and powers, the topic which you already learnt in the previous sessions. So let's take an example where mathematically I say that x power 2 times of 3 is equal to x 2 power 3, which is x power 8. Now the student has to identify and tell me whether this is right or wrong. If it is wrong, why it is wrong, the reasons for the wrongness. So that is how we identify the errors. So let's take the left hand side and simplify, and the right hand side. If you get the left hand side exactly identical to the right hand side, then we can say that the given statement is correct. If they are not equal, then they are wrong. And if it is wrong, why? The reason. We need to give the reason there. So in this case, I identify that x power 2 times of 3 can be written as x power 2 multiplied with 3, because I have the formula a power m whole power n is a power mn. This is one of the law of index which you already learnt in the previous sessions. Now this is nothing but x power 2 cube is written as 2 times 2 times 2, which is given to be this. Now taking three different terms of the equality, now let me see clearly. I understand that this is 2 times of 3 and this is 2 times 2 times 2. So whereas this step leads to 2 times of 3, which is 6. This step leads to 2 times of 2 times of 2 is 2 times 4, 4 times 2, which is 8. That is identically equal to x power 8. But this cannot be equal to this, because when the bases are equal, the powers must be equal. So 6 is not equal to 8. Therefore, my statement that this entire equation is equal is wrong. So there is something missing out here. There is some error out here which we need to identify. The error here is that when I have x power 2 times of 3 is written as x power 2 into 3, but it is immediately not equal to x power 2 cube. This is the reason where it fails. So it is not equal to this, and hence this will not be equal to x power 8. This is instead equal to x power 6. So the error identified here that this cannot be raised to power 3. So most of the students do the mistake by just writing 2 power 3 times of 2 as 2 power 3 power 2 as 2 power 9, and that is wrong. You're not supposed to take the power here. This is already in the power form. So both are different. X power 2 times of 3 is 2 into 3, and x power 2 power 3 is 2 times 2 times 2. So this is what the student needs to understand in the basics of understanding exponents and powers. Now let's go with another problem where we will try to identify the error existing in the given problem. So in this case, if suppose I have this is equal to this, I want to identify whether the given equation is right or wrong with the reasons. So let's simplify the left hand side and the right hand side and show that they are equal. If they're not equal, let's search for the reasons and then identify the error through the reasons. So when I take the left hand side, this is clearly understood as 3 times x inverse. This is understood as 1 by 3x directly. Now here x inverse is nothing but 1 by x. So therefore I get this as 3 times of 1 by x is 1 by 3x. Now this on multiplication gives 3 times of 1 is 3 by x is equal to 1 by 3x. Now this cannot be equal because the coefficient of 1 by x here is 3 and here it is 1 by 3, which cannot be equal. That is, 3 is not equal to 1 by 3. Therefore 3 by x is not equal to 1 by 3x. So the error here identified is that 3x inverse is equal to 3 times of 1 by x, which is 3 by x, which can never be equal to this. So here this is the error which is identified in case of the problem where 3x raised to negative 1 is equal to 1 over 3x. Now this would have been equal to this if this was given with whole inverse. If my 3x includes whole inverse of 1, then this can be written as reverse of this, which is very much true with the given problem. But because there's no bracket, I cannot just include this as 1 by 3x, but this minus 1 is assumed only for x, but not for 3. If in this case, minus 1, the power minus 1 is assumed for the entire 3x. So this is how we identify the various errors and then justify the statement through the reasons. And that is the end of exponents and powers. And there are many applications through which you're going to practice a lot of problems. And thank you.